everyone, today we are gonna talk about the advanced forecasting model with trends and seasonality. This is the actually use some data for continuously some more explanation that actually we have for the previous sessions. Some method for the forecasting, some models, and actually have a explanation, the total explanation about forecasting. But today we are gonna talk about more a bit about this situation, about the forecasting and some models, and use some examples that is more touchable for you. So the forecasting data that exhibits a trend, for example, an upward or downward pattern over time. Why important? Simple model is like averages or basic exponential smoothing fail to predict trends accurately. For example, sales of electric cars over the last 6 years show consistent growth. And for the next steps, we are gonna talk about the understanding of the trending data. Plot data to identify if a trend exists. So, how we should do it? The x-axis actually show us the time, and the y-axis show us the sales and or demand. We should plot this data in this axis and identify if points align in an increasing or decreasing pattern. For example, if we have some data about time that is encompasses of 1, 2, 3, 4, 5, and 6, for example, months, years, everything, according by is related in our question or in our some analyzing that we want to prepare according by these trends. Demand is encompasses of 26, 28, 29, 31, 32, and 35. Clearly, the data shows an upward trend. That means that if we want to plot this data, we have this that actually upward slope of the data in the linear regression, actually in the linear drawing or curve. So for the linear model for trend forecasting, for the forecasting, means that the trend forecasting, if we want to use the linear regression model, it means that the statistical method that fits a straight, the best fit, the straight line, means that the best fit to the data points. The formula of the regression is y equal a plus b t. A is the intercept and b is the slope of this curve, and t is the time for this per unit time for this actually circumstances. The steps of the calculating of according by the linear regression model. Calculate parameters a and b. If you want to calculate the a and b according by the linear regression, as I said you, the equation from this regression is y equal a plus bt. Okay, so for solving this equation, we should prepare or we should solve the a and b according by sum using the formula. Use the equation for if you want to achieve the number of a and b. You should use in the regression linear. You should use this formula. Sigma y equal n dot a plus bt plus b sigma t, and sigma y multiple t equal a multiple sigma t plus b multiple sigma t square. So for according by this equation, we should put our data in this equation, because if we want to solve the equation, we should use this equation for achieving the number of a and b. Solve simultaneously this equation. Four of the equations should solve simultaneously, because according by this we can achieve to the a and b. So the example of the linear regression, imagine that the time is consists of 1, 2, 3, 4, 5, 6, and the demand y is 26, 28, 29, and so on. Actually, the calculation of this is, if we want to have a sigma y, means that the sigma y you can have the total of the y. I mean that's the 26 plus 28 plus 29 plus 31 plus 32 and plus 35. The total of this is equal 181, and for the sigma t equal is 21. If we have a plus from these numbers, actually we arrive this total number, the 21. For the sigma of y multiple t, means that for example 1 multiple 26, 2 multiple 28, 4 multiple 29, 3 multiple 29, 4 multiple 31, 5 multiple 32, and 6 multiple 37. We arrive there 663, and the square of the t, the sigma of the square of the t, each of these data should be have a square, and after that we should have a plus together, and in total it is 91. Solving according by this, we should put this data in this formula that I said to you, and actually we can arrive to a and b in the a and b from this equation. Forecasting future periods. So for period 7, when imagine that we want to have some forecasting for the period of 7 according by the regression model, we should just put the for the equation of the regression was about y equal a plus bt. So a is according by this data that we solve it, the a is equal 24.27 plus the b is equal 1.69. So instead of the t, we should put the period of 7, so it's for the year of the 7, and it's the we achieve the, or we arrive the number of 36.07. The result forecast for period 7 is 36.07. So it was about the regression model. If you want to have some trend about some data, you can use the regression model. So and the whole models or methods for trend forecasting. This model enhances exponential smoothing by incorporating trend adjustments. The formula of the Holtz methods is ft plus 1 equal at plus bt. So at is the level or smoothed value of demand up to t, and bt is the slope, the rate of change in demand at t. Updating the equation, we have two equations for the model or method of the holes. The at equal blah blah blah, and bt is equal blah blah blah, and this that you can see in this session. So the steps of this, what should we do? For the steps of this is set initial value for the first step. Set initial value according by this data that I said to you. For example, for A1 is for A1 it was 26, as you can see in this. For example, here A1 is 26. Okay, A1 is equal the 26. So B1 was the 35 minus 26. Then we want to have a some calculating for the B1. How we should find this? For the B1, we can have, for example, the 26 minus 28, for example, divided by 5. Why 5? Because the 1, 2, 3, 4, 5. 5 level or 5 years, 5 data, 5 times we can use or this data. So instead of n, we should use the 5. 35 minus 26, the first one and this last one. So for this, the first one minus the last one is divided by the 5, because the 5 times from this 5 times we have this data that for using for calculating we should use the 5, and after that the 35 minus 26 divided by 5 is equal 1.8. Smoothing constant alpha is assumed that this is the assume that according by something that happened, that the data and the question said that the alpha is equal 0.2 and beta is equal 0.3. Compute forecasting iteratively. So for the F2 is equal A1 plus B1. So according by this, we found that the A1 and plus B1. A1 was 26 and B1 was 1.8. So the total of this is 27.8. And A2 is alpha multiple D2 plus 1 minus alpha multiple A1 plus B1 is total is equal 27.84. And for the B2, according by using the formula, we arrive this 1.85, like this situation that actually in previous we used the data from the first and data from the last and divided by the 5 times. So the F3 is equal this according by this formula, and putting some data in this formula we can find the other F, for example F3, F4. F3 is A2 plus B2, F4 is A3 plus B3, and so on. Final exam. Final example, period 7 forecast. Period 7 forecast, for example, if we want to have a forecast for the period 7, just we should use the A6 plus B6, like the A1 and B1, just A6 and plus B6. According by putting to this formula, you can find this data. It is very easy that just you should put in this data in this formula. So for the forecasting for the period of 7, our calculation total is 36.32. The Holtz model gives a slightly higher forecast, that's 36.32, compared to linear regression. As you can see in the linear regression that before of the Holtz model, we found that the 36.07, and according by using the Holtz formula or methods, we find that the forecast is 36.32. The advantages of this model is captures recent data effectively and adjusts both level and trend dynamically. So the next one is the simple seasonal model. Simple seasonal model captures seasonal variations in data, calculate seasonality indices, index for example quarter 1. We should use the demand in quarter 1 by dividing to total demand. For example, the year 1 it was the uh, 53 divided by 157. As you can see, the year 1. Oh, I forget that bring for you the this example, the data of this example, but the data for this example for the year 1, we have the demand in quarter for the year 1 was 53, and for the year 2 was 58, and the total of the demand is the plus of this actually 2 years, and is equal of the 157, that dividing the demand in quarter 1 to total demand is 337, and for the year 2, dividing for the demand in quarter, for example 2 is 5 58 divided 173. According by this, we are arriving to this number, 335. Average indices across year quarter 1 is the the total of these that actually arrived them, divided to 3 for the quarter 1, for example. And the forecast using indicates total forecast for year 4 is 205 from linear trend, and quarter 1 forecast is 205 multiple 0.30, 337 is equal 69.08. So Repeat for other quarters. According by this that I explained for you, you should repeat for other quarters. So the year four quarterly forecast. The year four quarterly forecast is the quarter one, quarter two, quarter three, and quarter four. We can arrive this according by putting the data in this formula. We can arrive this data. So the next steps explore advanced methods like Winter's model for combined trend and seasonality. Winter model. So what's the winter model? Winter's model is an advanced forecasting method that uses exponential smoothing to simultaneously predict level, trend, and seasonal indices. Formula forecasting for the future period: ft plus m. ft plus m is equal at plus bt multiple m, and totally is multiple s p minus index of this is p minus m plus t. At is the level or smoothed average, bt is the slope rate of trend change, and st plus m minus p is the season index for the desired period. P is number, actually P is a number, a P in this here, and for the index is a number of seasons in one cycle. So, updating the level IT. For the level IT, if you want to, or if we want to calculating the level IT, we should using this formula and updating the slope BT. For the BT, we should using this formula for achieving the BT numbers. And updating the seasonal index is st is equal gamma multiple t dt divided at plus gamma minus 1 in total is multiple s t minus p. For example, the data of this question is year one is the encompasses of 53, 22, 37, 45, and for the year 2, year 3 we have some data. Initial indicates that the alpha we assume that the alpha is 0.4, beta is 0.2, and the gamma is 0.3, and the A1 is D1 divided to S1. So the steps of the calculating of this the Winters models, we should calculate average seasonal indices. For example, S1 is 53 multiple to the total of the demand. So it's this, and this is forecast for the fourth year. Y is equal 205, as I told you, according by putting some data in the previous formula, we can arrive to the 205. Forecast for the quarter one is equal 205 multiple S1 is 69. Actually 69.08. So according by this explanation, in totally I want to say you the basic model of the forecasting is encompasses of simple averaging for constant data, linear regression for trending data, and the seasonal model for periodic data. It has some advantages and disadvantages. Simple model is the quick and very easy. This is the good advantages of this model. And the low accuracy for complex data. This is the disadvantages of using this model. That the complex models that it encompasses of holes and winters has some actually advantages and disadvantages. Advantages about this is high accuracy, and disadvantages is computational complexity. You know, but it is very important that you use this formula and these methods according by your request, according by your analyzing, according by your um, uh, expects business. It's very important that according by your needs you should choose, and your needs means that your business needs, your, for example, job needs, you should choose this kind of methods and have some forecasting. The result from these methods most of the time is very same as together, is very like together and close together, but sometimes it's maybe have a bit difference between them that is not very important for impacting. Thank you guys. Today we're gonna finish the actual lecture and finish the this presentation. I hoped that you find that something important points about the or crucial role about the forecasting in your business, or and actually you find some methods and the models for having some forecasting, and actually according by this presentation we mentioned some points and some advantages and disadvantages about these bullet points, about these models, and you can use according by your request business, and I think it is very useful for you, and you can use it, and I hope I can have a more presentation about other topics. Thank you and have a good time.